You know that feeling, right? You're tracking a package, watching that tiny little van icon just crawl across the map, and you can't help but think, why isn't this faster? Well, today we're going to break down some fascinating new research that taps into the seriously strange world of quantum computing to maybe, just maybe, solve that exact problem for good. So, let's just start with the big question that I think we've all asked ourselves while waiting for that out for delivery notification. I mean, we live in an age of instant everything, right? You'd think getting a box from a warehouse to your house in just a few hours would be a totally solved problem by now. But, well, it's anything but. And here it is, the heart of the issue. For any normal, classical computer, trying to find the single best route for a whole fleet of delivery vans is a complete mathematical nightmare. The number of possible routes doesn't just grow, it literally explodes. We are not talking about thousands of options here. For Big City, we're talking about more possible routes than there are atoms in the known universe. Yeah, no joke. Now, this whole puzzle has a name. It's what creates the last-mile traffic jam, that final, frustrating step from the local hub to your front door. And it's exactly why that last mile is the most expensive, the most polluting, and the most inefficient part of the entire journey. In the world of computer science, they call this an NP-hard problem. And all that really means is that as you add just a few more stops to a delivery route, the number of possible paths, it just goes vertical. It explodes exponentially. You very quickly get to a point where finding the one, single, perfect route becomes practically impossible, even for the biggest supercomputers on the planet.
Okay, so if our current computers are completely stuck in this traffic jam, how in the world do you solve a problem that's nearly impossible? Well, you have to turn to a totally different way of thinking, a completely new kind of engine for computation. The fundamental difference between the computer on your desk and a quantum computer really boils down to this. A classical bit, right, it's like a simple light switch. It's either on or it's off, a 1 or a 0. But a quantum bit, or a qubit, it's more like a dimmer dial. It can be a 1, it can be a 0, or it can exist in this kind of fluid, in-between state of being both at the exact same time. And that is what allows it to explore every single potential delivery route all at once, instead of having to check them one by one by one.
This incredible power comes from two concepts that are, let's be honest, genuinely mind-bending. The first is superposition. That's the dimmer dial thing, the ability to be in multiple states at once. And the second is entanglement. This is where two or more qubits become mysteriously linked. Their fates are tied together no matter how far apart they are. You put those two principles together and you get a computational toolkit that is unlike anything we have ever built before.
So, you've got this amazing new quantum toolkit. How do you actually use it to solve our delivery problem? Well, the researchers didn't just throw raw quantum power at it, hoping for the best. No, they came up with this really brilliant hybrid approach, basically teaching this new power how to think about the problem. So, I want you to imagine a brand new trainee delivery driver. That's the reinforcement learning agent. It learns by trial and error, right? It makes some deliveries, it gets feedback on how it did, and it slowly gets better over time. But here's the twist. In this experiment, the trainee has a revolutionary new quantum brain, what the paper calls a parametrized quantum circuit, or PQC for short. And this quantum brain has a pretty cool four-step process. First, it uses superposition to consider all possible routes at once. Then, it encodes all the real-world stuff, vehicle capacity, delivery time windows, locations, into the qubits. Then comes the magic trick. It uses entanglement to create a direct quantum link between where a package gets picked up and where it needs to be dropped off. And finally, through learning, the AI agent guides the circuit, tweaking it over and over to make the pathways that lead to the best routes stronger and stronger. And the real beauty of this whole design is just how efficient it is. Its complexity scales linearly. Now, what does that mean? It means if you have n number of stops, you only need n number of qubits. So if you double the number of delivery stops, you just have to double the number of qubits. This is a huge, huge leap forward. It makes the whole thing scalable, from a small neighborhood all the way up to a massive city, which has been a major roadblock for other quantum ideas.
Okay, but the big question, the one we all want to know is, does it actually work any better? Is it faster? To find out, the researchers put their new quantum driver into a head-to-head race against some of the other top methods out there.
All right, so here are the contenders in our race. In one corner, we've got two powerful but classical AI champions, DDQN and PPO. In another, we have a different quantum competitor called QSVT. And of course, we have our new hybrid agent, the PQC-RL, our quantum driver. So, who won? Well, when they looked at the average total travel time, the results were pretty decisive. While all the methods did pretty well, the new PQ-RL agent, our quantum driver, consistently found smarter, more efficient routes, and it achieved the lowest overall travel time of the bunch.
And the authors themselves really spell out why it worked so well. See, it wasn't just about throwing quantum power at the problem. It was all about how they used that power. It was that unique structure, specifically those layers they built to really take advantage of the entanglement between pickup and drop-off points. That was the secret sauce.
Look, this is way more than just some academic win in a computer simulation. This points toward a future with massive, real-world implications. We're talking about something that could change not just how you get your packages, but maybe even the very fabric of how our cities operate.
So, what's the bottom line here? What should you take away from all this? First, this research shows that a hybrid quantum AI approach isn't just a cool theory anymore. It can actually solve incredibly complex real-world problems, and it does it really efficiently, needing less training than the old-school AI methods. Now, we gotta be honest, it's still early days. These tests were run on quantum simulators, not on full-blown quantum computers yet. But even so, this shows a powerful new path forward, a way of combining these two revolutionary technologies.
And that really leaves us with one last big thought to chew on. For decades, the last-mile delivery problem was seen as this impossible logistical nightmare, a mathematical monster that was just too complex to ever truly solve perfectly. If we are now on the verge of cracking that, what other unsolvable problems in designing new medicines, discovering new materials, or understanding financial markets, what will we be able to tackle next?